we should understand that this descriptive statistics actually, one is central tendency, which is calculating the averages, the central points, whereas on the other hand we have which is calculating the variations, okay, or variance, which we call the variations, like a range, standard deviation. Let me just open for you. Yeah, for example, measures of variations, we have range, we have standard deviation, we have variance, so because it helps us to know about the dispersion of data, how far my mean, my standard deviation is, because, and we can also learn, if you recall my example about the two players, that now which player has more variations, or which stock, has more variations, you are not going to buy actually. As far as the calculation, and also we calculate CV, which is called the coefficient of variance, or the variations. For example, let's say I have this this question already I have written for you, that two different brands of light, this is in weeks actually, the first bulb for example, and I have taken sample or population, whatever you say, let's say random sample. So 20 weeks, the first bulb, the second week, 34 is the second week, 30 is the, sorry, 34 is the second bulb, 30 weeks is the third bulb, likewise. And I have another company, which produces bulbs, but 10 weeks, it lasts, and it lasts 20 weeks, it lasts 30 weeks, and so on, so forth. So now when you are given an option that which bulb actually, or which company you would like to prefer, in that case actually we see, because if you rely on median, the Tilak, I think he was asking yesterday, that if you rely on median or mean, that won't give us the exact answer. We need to know the variance actually, we need to know the variation. For example, range, though a range, though it seems to be very simple, so from highest to lowest, or lowest to highest, if I draw the simple chart, for example, I have this spread of data, and let's say B company, okay, this is my B company. I'm starting from 5, 5, 10, 15, and let's say up to what's the maximum is 70, let's say. So the variation of my B company starting from 15 to 60, so 60 will fall somewhere here, it will be something like that. But now look at the, for example, the A company. If you, the same chart, if you prepare, from 5 to 70, from 5 to 70, again 15, 15, and so on, and from here you would see that 20, so the variation will fall somewhere between 20 to 55, 20 to 55, 20 to 55, somewhere here actually, let's say if it is 55 or here. So you can see now this variation. So which has more variation, company B or company A? Of course company B has more variations actually. So and coefficient of variation is the formula of coefficient of variation is it considers two aspects. One is the mean, second is the standard deviation. Actually, it is believed that most of the statisticians believe that if you look the standard deviation against the mean and multiply by 100 in order to know the percentage, so that it can give you somehow, because now you may say that if you calculate the mean, for example, of this, let's say the mean is 50, or the mean of this company is, let's say, 60. So on an average, you may say that company B tends to be, performing well, because this says that the bulb can last up to 60, which is the average. But when we look at actually the range, we find that no, it has actually more variation. But then we have coefficient of variation, which says that no, what we need to do, that standard deviation divided by mu, or if we have sample, then standard deviation divided by mean. Why? Because this is the ratio actually, that standard deviation is equal is to mean. that what is the average standard deviation against the average mean. Okay, and then if you want to know the percentage, then you simply multiply by 100, so that you can get the accurate answer, right? Let me give a small example. Again, the same thing about the variance, because if you look at the formula of variance, what how to define the variance actually. If you look at the formulas, what we did in the first class. Okay, let me just do it here. Okay, the steps of what was the step for first we calculated the simple, x minus mean. Okay, let me just write down mean. It is easy to write x minus mean. Then what did we do? We simply x minus mean whole square, isn't it? In the second step, if you remember my standard deviation calculation. And then what did we do next? Sorry. Then we sum up. We see sigma divide square. Okay. And then what was the next step? Our next step was that we put actually the square root, but also we divided by n. Why? The division of n, or n minus 1, okay, in case of sample, this in this case it will be n minus 1, because I have taken mean n minus 1. Why? Because just to get the average. Okay, and this is basically our standard deviation, or SD, or SD square. Are you getting my point? And this SD square is called actually the variance within data. What is the amount of variation, right? And the moment you put actually square root, and then it simply becomes standard deviation, and formula remains the same, x minus mean whole square divided by n minus 1. So in calculation, this is the difference. But then why do we need coefficient of variation? Now the question comes, the simple answer, that what is the ratio between the mean and standard deviation. I'm calling the same example A and example player A and player B. Okay, let's say player B mean is given. Okay, on an average he makes 3 goals. Okay, B makes, let's say, 2 goals, or hits 2 goals. Okay, we have also given standard deviation. Okay, let's say standard deviation is 2, standard deviation is 1, right? um, if you just look at the mean, I think A looks better. If you look at the standard deviation, B looks better. Now you are confused that, okay, so which one we should, the player we should go for. And then we have next formula, calling coefficient of variation. Simple, let me, the formula standard deviation divided by mu, or in case of sample, if I divide, let's say, and multiply by 100, sorry, and if I do this, let's say my standard deviation is 2 here, my mean is 3 here, okay, multiply by 100. And in this case, my standard deviation is actually 1, my mean is 2, multiply by 100. And how much, what is the answer? 2 divided by, if I calculate 2 divided by 3, multiply by 100, it's going to be 66.7% variation. And in this question, 1 divided by 2 multiplied by 100 is equal to 50% variation. So who has got more variation? Because it is called coefficient. The word English, co is used when we have two elements like coordination, cooperation between two people. So coefficient is always used when you compare actually two data sets, right? Or two players, or two stocks, or something too. So how efficient they are within. So when we look at the coefficient of variation, okay, it seems that A seems to be more volatile, seems to have more variation, whereas 50, the one who has got 50%, seems to be more, the word I should use, consistent, that his consistency, as far as hitting the goals are concerned, is better than the A. So this is the concept of coefficient of variation, that why do we calculate coefficient of variation? Just to see, not only considering the standard deviation, not only considering the mean, but along with the mean and the entire this, as I have written, either it is range or standard deviation or variance or covariance. The main purpose is to see the variations within the data. Okay, But if you are looking for the central, some measurement of central tendency, then you just go for mid, mode, median. Okay, that can help you. And I think one line. I hope it is clear. Okay, now our next topic, which is again a very important, called correlation. Okay, then afterwards we will move on to the, because I will also today discuss correlation on or through SPSS. So let me just start with, because I need, okay, correlation. So again, when we correlation between the two variables, I don't have to explain the meaning, because it is very clear that when you are trying to figure out the relationship between the two variables. Okay, so why do we see the relationship between? Because we may have several research questions and hypotheses related to correlation. For example, what is the correlation between the genders? When it comes to going shopping, for example, or cycling, for example, that who's or what is the correlation between, or does it have any correlation, or is it negative correlation, or is it positive correlation, or there is no correlation at all, right? So correlation has several properties. We would be looking one by one after this formulas and all, that what kind of correlation exists between the two variables. Now, the next step of correlation is regression. Why? Because if we have, let's say, good correlation between the two variables, so how it can help us? It can help us predicting. For example, let's say my correlation with my subject, okay, my statistics, the subject I teach. If I have good correlation with my subject, then one can predict that I can push my career towards positive direction. But if my correlation, or if your correlation is not good with your subjects, then what would happen? So prediction, what we call regression in statistics language, that how does the value regress, that regression actually is going to be helpful with the we can do prediction, okay, or regression with the help of correlation, but if only when there is a correlation. So today we are not going to only learn how to calculate the correlation, but also see the properties. When can we call that correlation is positive? When can we call that correlation is negative? When can we call that there is no correlation at all? And what are the factors and what are the points that we have to keep in our mind before calculating the what we call the correlation. Okay, so for the definition, you can go through the book. You can find several definitions over there. Okay, I'm just directly coming on to the two important figures actually. Who one is Karl Pearson. Okay, Karl Pearson, Spearman. The Spearman's correlation and Karl Pearson correlation formulas. Okay, for calculating correlation. Okay, anyways, so let's start with Karl Pearson first. As I have said, uh, let's start with the mathematical formulas, and then we will see the, let's say I have two variables. I can assume, okay, any two variables, x or y. You can name any, okay. My x variable is actually, let's say 3, 3, okay, uh, 2, 4, and 3. Okay, my y variable is 1, 2, 1, 3, 2. Okay, I need to know, does it have any correlation? Okay, does or do x and y make any kind of sense or not? Or they are just hypothetical figures which will not be which will not be helping us to predict. Because what we can do, for example, if let's imagine that if it is my advertisement, okay, if it is my advertisement, if it is my sales, okay, so I say if I do $1 advertisement, so I can do $3 sale. Okay, if I do $2 advertisement, then I can do $3 sale. If I do again $1, or at one point of time, for example, if it has time period, involved, the first week I spent, $1 or advertisement, and then I had $3 sale. The second week I spent $2, on advertisement, and then I did $3 sale, something like that. So I can ask you a simple question that, hey, if you spend, let's say, $5, what is going to be your sales, So, but before you actually find out, and that is called regression. So if you, before you find out, you have to see, do they have any kind of relationship or not? That's what I was talking about. So to know the relationship, and also I forgot to inform you, this correlation is represented as R, okay, R. So whenever you see R, it means that simple correlation, and regression is represented as R square. So I'm writing here regression is because of method of least square that we'll be learning. Okay, it's called regression, and this called R. Okay, so today we are looking at R. Let's move on to the formula. X, let me just 3 3 2 4 3, y is 1 2 1 3 2. Okay, our next is, so the formula, let me just first of all write down the formula. It is, okay, sigma xy minus sigma x, okay, sigma y divided by n. Okay, small n or big N, it doesn't matter actually in this question. Okay, and under root. Are you going to remember these formulas? No, well, not really, but in order to understand, because when you run all these, on system, you will not be able to actually figure out, or it will not give you the formulas, It can on different software when you need it, but normally it does not. Sigma x square, minus sigma x, okay, or square divided by n, or big N. If I have used big N, let me use, otherwise you will get confused. Next is actually, let me put sigma y square minus sigma y whole square divided by n. Okay, now, so what do we need? Now, according to the formula, we will be calculating. For example, first we need sigma x. So sigma x means x means total of x, which is 339 plus 11 plus 4, 15 plus 3, 18. No, nothing, 3, 6, 8, 8, 12, 3, 15, isn't it? Correct, yeah?
15.
Yeah.
Yes, 15.
Okay, 2, 3. If I make a mistake, please let me know, okay? Because I am not using calculator or phone. 2, 1, 3, 3, 6, 7, 8. Right? Okay, now what I need sigma x, and this is my sigma y. Next is what do I need? I need sigma x and sigma
I
x.
think it's
It's
I think
9,
it's
it's
9.
not 8, yes.
Ah, really? Yeah.
I think so.
Yeah. No, I imagine, because 9, yeah. Okay. And 2, 4, 3 is okay. And now we need xy. Why we need xy? Because we need sigma xy. So sigma xy. So it is 3, 6, 2, 12, 6. So it is going to be 6 plus 3, 9 plus 2, 11, 20, and then 21, 22, 26, 28, isn't it?
29.
29, yes.
29, yeah, 29. Okay, and then next we have, what do we have next? Sigma x square, and we have to find sigma x square. So let's do x square. 9, 9, 4, 16, 9, isn't it? What is the total? Can you tell me what is the total? And then we also need sigma y square. So sorry. So we need y square Okay, so you tell me please the summation of sigma x square.
47.
47 for x.
47 for x. And what about this? 2 to 4, 1, 9 to 4. So what is going to be?
19.
19. Yeah,
19.
19. Now,
19.
yeah, if you put all this in formula now, let's put this in formula and then you will tell me the digit. So sigma xy, this is sigma xy. Let me change the color. So this is sigma xy. I'm going to put 29. Okay, minus we have sigma x, sigma y. So 15 multiplied by 9 divided by number of observations. 1, 2, 3, 4, 5. We have 5 number of observations, right? And then next is actually what is sigma x. It should be actually big. What you call, anyways, like this, because we have already
Sorry, sir. I think sigma y is 10, not 9.
sigma y is 10.
Yeah.
No. Why? Sigma y is 10, 3 through 5, 6, 7, 8, 9. It says 9, isn't it? So sigma x,
Yeah, it's 9.
yeah,
It's 9.
Sorry.
no problem. Sigma x square is 47. If I'm not mistaken, sigma x square is 47, yeah, minus sigma x whole square. Sigma x is 15 square divided by how much it is? 5 actually. And then we have next is sigma y square. Sigma y square is actually 9 minus sigma y whole square. No, sigma y square is 19. Sorry, I made a mistake here. Sigma 19 and sigma y is actually 9. Okay, square divided by 5. And you can actually calculate and you can tell me the answer. Can you tell me the answer if you calculate? Can you do this? All right. Quickly 14 divided by so I think it would be 2.
0.36.
Okay, so you can calculate and he says 0.36. So correlation is 0.3, right?
I found another,
What did you find?
yes, 0.84.
Oh, really?
Yes.
So 0. Okay, I'm also writing. Maybe other student will tell me 0.84. Yeah, any other? Let's see comparison. So remember that you have to do this 47 minus. First you calculate this. So 15 multiplied by 15 divided by 5. And then also there is a square root. Don't forget, you have to calculate the square root also. First you solve the inside equation and then you calculate the square root.
Can you hear me?
Yes, I can.
1.1.
1.1 is not possible. Because
Not possible.
no, not possible. Because correlation cannot be more than 1. It is between -1 to 2 plus 1.
We should divide 2 to 5.6, and it will be 0.36.
0.
But
Okay.
5.6 is under the square, I think. Yes.
So
Yes. So answer is 0.84.
0.84.
Yes.
How about the other students? Are you calculating the other students? Are you there?
I have the same answer.
Sorry, 0.84. I
Okay,
didn't calculate the square.
Okay. So this is not the answer, no problem. So 0.84. Now, if I ask you, the relationship has come like 0.8, do you think it's a good relationship or it's a bad relationship?
There is a strong positive relationship.
Yeah, so it is not very strong, but it is called strong relationship between so this is actually the method given by Karl Pearson. Okay. And let me just take you to this one. So here, I took it from the book actually. You can see here how to recognize that relationship is, bad, good, or worse. So relationship moves from -1 to +1. Okay, -1 to +1 always. So when R is 1, it means the relationship is very strong. Okay, we will also draw this chart. If we plot let's say on graph, for example, this is my x-axis, this is my y-axis, and the what was the digit actually? What was the digit? No, this is the big problem actually when we know. So okay, let me just draw the chart. Let me just draw the chart, graph, sorry. So when we put on 0x and 0y, so 1, isn't it? 1, 2, 3, 4, 5. And here also we can put like 1, 2, and 3. Okay, if we look, for example, when my x was 1, what was my age? My age was actually 2, isn't it? Yeah, is it correct or no, when it was, remember, sorry, wait, when it was 2, my x-axis was 2 actually. What was my y? My y was 1. When my x was 3, my y was, what was my y? My y was 2. Okay, so when my x was 4, what was my y? My y was 3, right? When my x was 3, again my y was 2. So what sort of relationship you can see on it shows that there is a actually positive relationship, isn't it? So when you draw this graph, it shows that there is a positive relationship between so even though your R is, let's say, is approximately 0.84, which itself close to 0.9 actually, which says that it's a good relationship. Okay, so but from the chart also, just you draw simple, dots. From dots also you can understand the relationship is very much positive, right? Okay, now when R is equal to 1, it shows that perfect positive linear correlation, which means that perfect relationship. When R is actually is equal to 0.9, it means that strong positive linear relationship, not perfect, but positive. And when R is lesser than 0.5, 0.4, it is called weak positive linear correlation. Why do we need this? We need just to explain whether when we are interpreting our results actually. Okay, so when R is -1, it is linear, perfectly perfect negative correlation. And when we have strong negative linear correlation, R is equal to 0.9. When we have weak negative correlation, R is equal to 0.04. And when there is no relationship at all, then R is equal to 0. And of course, when you have no relationship, so points will draw something like that, isn't it? So when you have negative, again, this will, instead of this, it will actually go down that way. Okay, so this is one way of calculating correlation between the two variables. And the other way we have is called Spearman correlation. So let's look very quickly and then we'll move on to a different topic. Spearman correlation. Okay, Spearman correlation, as far as the answer is concerned, as far as the interpretation is concerned, you will not find a big difference between the two answers. For example, Karl Pearson, if Karl Pearson says 0.8, then you would hardly see in Spearman's answer or the interpretation that R is going to be positive, or I mean what you call perfectly positive, like above than 9 or 9.995, but it's just another method, and just way to calculate the correlation. So the formula of this is actually 1 minus 6 sigma d square upon n square minus 1, and sometimes people say n cube minus n also, that is also possible. Okay, so I'm having a small question very quickly, and then let's look at, let's say we have again two variable. Okay, 17. Okay, I'm 13, 15. Okay, 16, 6, 11, 14, 9, 7, 12, and we have y. Okay, 36, 46, 35, 24, 12, 18, 27, 27, 22, 2, 8. Okay, now what do we do? First of all, we actually calculate the D. So basically it is also called rank correlation. Rank correlation. Okay, because you are actually going to rank the digits. Okay, so rank correlation, for example, here X, here simply Y, and then you simply say 17, okay, 13, 15, okay, 16, 6, 11, okay, and here you have Y, let's say 36, 46, 35, after that 24, sorry, and then 12, and then 18, and then now rank 1, okay, and then rank actually 2 in that case. So 17 would be your first rank, 15 would be yours, 16 would be yours, sorry, 16 would be your second rank, it will be your third rank, right? And then what you do here, and for example, after let's say this is your fourth rank in this one, and in Y case that would be your first rank, I think 46 in this case, 46, and this is your second rank, this is your third rank, this is your fourth rank, and then what you do, you simply 1 minus 2, for example, R1 minus R2, 1 minus 2 1 minus 1, 4 minus 1 is 3, 3 minus 3 0, 2 minus 2, and then you simply, this is called D, and then simply you do the D square, 1, 3, 3, 9, 2 to 4, and then you do the calculation, and after that 1 minus 6 sigma D square, because this is going to be sigma D square under root n square minus 1. In this case, n is basically number of observation we have. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 square, it would be 100 minus 1, and then you would find the R. Okay, you can do it at home. I think it's not very difficult, and that's also okay, but it eventually the answer would be actually related very close to the Karl Pearson one. So what you can do, my previous question at home, I can give you a home assignment also. The same question you can do by two formulas. Okay, the same question and apply both formulas, and you will find almost the same answers. Are you getting, is it okay? I hope you understand. It's okay, right?
Yeah.
What's the BCR up there?
Sorry, your voice is not clear.
Professor, can you see, please, what does it stand for, the letter before the sum after minus 1?
So actually, your voice is not clear, but you are asking about this, isn't it?
No, I'm asking about the after minus 1, the sign. Is it sigma or what? In the formula.
This one is 6. It is actually formula is 1 minus 6 sigma d square divided by n square minus 1.
Thank you.
Welcome. Okay, so let's this is actually called correlation. Again, the properties will remain the same. Can you see my desktop?
Yes.
Yes.
Okay. Okay, good. So now I will be actually using the same data that we have, for example, for histogram and for so first of all, tell me how many of you know actually this already. How many? Can you please write to me in message box, those who have or those who know a little bit about that. Greetings. Hello. So who knows already this little bit, just to know your background. And in the beginning of the first session, there was one or two students who said they do not have background. So are you okay with now? Are you learning? Are you able to understand the concepts? I forgot the name of that girl actually. Who was she? The one who has security background, politics. Are you getting the points or not? Is she there?
You mean Professor Nara? Yeah.
Yeah. So are you now able to understand?
Yeah, I am able to understand. And yeah.
Okay, very good. Okay, so
I'm also watching the videos you sent to the group.
okay, so I'm actually, for example, today's correlation was very simple, but I still focused on so that students like you can also have a sense of why, because now the software we will not be calculating the formulas or learning the formula. You don't have to learn the formulas, to be honest with you, but if you have good understanding, that is going to always help you. Okay, now this is the software that I'm going to use, and I hope everybody has now in her or his computer. If not, please do it this weekend. There it has two actually, you can see that data view and the variable view. So data view is the where you put all your data set, okay, and variable view is where you actually define your variables, okay, and variables you know already, like for example, and whatever the variables you define here, it will be shown on this screen. Okay, so let's say, for example, age, okay, age, and then the next column, it would ask you that, what is this? This is number. Most of the time, data is because, and particularly you guys, that you are not a student of psychology, and so your data is most of the time, numerical data, okay? So it is up to you, either you put it in a string or you put it in numeric. It is not going to actually affect your, because age is very, it is defined in numbers most of the time. Oh, sorry, all the time. But if we have another variable, which is called, let's say, gender. So in gender, male or female, but then we have to define male and female by 1 and 2. So again, yeah, either you put it in numeric or string, but it is always better. For example, myself, if I do any analysis, I always put my data in numeric and it does not actually affect. Okay, now the next is width. Width is the characters, so it is by default 8 all the time. You don't have to change until and unless it asks you, and it gives you an error, error pops up on the screen. So, you will understand. Then now the decimals, the decimal should be 0 until unless it is required. For example, some data, let's say you are doing research about inflation. So in inflation, you have always decimals, because prices do not always increase, as whole, but they increase like 10.2, 10.3. So point, this is decimal, but today we don't need decimal always. Labeling is actually the explanation, okay, that what, for example, age, so I can explain here. This is always going to help us, because when you have, let's say, 15, 20 or 25 variables, then this labeling is going to help us to understand, to recognize, to remember. For example, age of my students, okay, age of my student, this labeling, whatever you like, okay, whichever language you like, you can actually explain. And now the next is very important. It's called the values. Here, actually, you have to define the value, okay? In this case, you are not going to, but in gender, In gender, what you're going to do, let's say 1 labeling male, okay, 1 stands for male and 2 stands for female, right? And 3, if you have another gender and your study is considering that, but mostly we don't. But if it's the nature of that gender, of course. So this is likewise. For example, when you are asked a question like about satisfaction level, so you are going to ask a respondent that are you satisfied with the quality of life given here and there, and then they say 1 for example, I'm writing here satisfaction. But one thing you have to remember that it does not accept the space. Okay, so what you're going to do, you're going to put always underscore. Okay, underscore. For example, if you give space satisfaction level, you see it will show variable name contains illegal character. It will always show. So it is better not to. For example, likewise you can do, and it will accept satisfaction and then underscore level. Okay, and now it has accepted. Okay, satisfaction level. Name, and of course it is going to be defined in 1 2 3. Decimal remains 0 because and then here I'm going to for example 1 is highly satisfied, highly satisfied, add number 2 is not at all, not satisfied. I'm just saving my time. And then third is yes, no answer. Sometimes people don't want to answer, so no answer. And then you can actually put it, and this is where you put the value. Now missing. So missing is also very important in all the time. Whenever you have SPSS sheet, it will be showing as separate column that missing. So what is missing? And let's say you have a very big data, 10,000 values, okay, or the digits, or 5,000 digits, and then you are human being. We are human beings. We can make mistakes. Maybe by mistake, for example, let's say I am putting my data here. The age is 21, okay, 23, 25, and then by mistake I forgot. Like look, you see this, I forgot that. So in this case, what you can do, you can create a value which can help you to understand that okay, so this is missing value. For example, you just put it here as, let's say it will ask discrete missing value. If it is asked, let's say 999 or something like that. Okay, so whenever in data it will pop up, or in when there's a what you call the results, when you have results from SPSS, it will show you that missing value 999 2 3 4 5. If you have forgotten 10 columns, it will show you 10 columns. Okay, so this is also important if you have very big data and if you feel that you might make mistake. Okay, in that case it will always. Right, now the next is column. Again, column is alignment is like this side or that, that's not very important. Now measures important, and I'm going to discuss a little bit about it because this is introduction class, so I want it to be the whenever you go turn on measures, it asks you 3 things. Actually we have already discussed in our second class last week, the last class, the scale, ordinal, and nominal. So the scale, basically, as I told you, what you can measure on scale. Okay, example, height, weight, I don't know, speed, whatever can be scaled. Now next is ordinal. Ordinal, which can be ranked. For example, this one. Okay, this one. So it is not ranked. For example, who eats more. Okay, there are 3 guys, A, B, C. So you are ranking that C, the highest, and then B, and then A, and so on and so forth. So whenever you have what you call unranked data, ranked data, which you can actually rank, always remember that you can rank, or you can also understand from OR, ordinal, order. You can put, in order, that is always put it as ordinal. If it is not ranked, like my eye color, your eye color, your hair color, your skin color, because we cannot put it in ranks, and that is called the nominal data. So I always remember when I was learning this, my teacher told me, and it always helped me actually, that whenever data is ranked, go for ordinal. When data is not ranked, go for the nominal. Now the next question comes as, if we make a mistake, I'm sure you must be thinking that if we make a mistake in measure, that is it really affecting our analysis? Actually, to be honest with you, it is very debatable, and to great extent, no. But again, it depends on the nature of study, that how sensitive your data is. If data is very sensitive, like stock markets, and then it might affect, but normally it does not. Role input, you just don't have to touch, it remains the same. Do two columns, don't touch, okay? Alignment and role, okay? Values, labeling, decimals, as I have said, until and unless, needed, you don't have to. Now you create, so what you have done here in variable view, you create the variables. How to delete? Simply go to this one and clear. You can, and if you want to clear it, it will be deleted from here. You can create maybe 5,000, 7,000, 8,000 variables, and you can do. You can also export, from Excel. I will also discuss in my next class. No, next class we will be learning probability. Next class I will be discussing how to import your data from Excel, how to save your data, and all that thing. We can import is a little bit tricky, from export and from Excel and other, because actually as far as the organization of data is concerned, I still prefer Excel, because in Excel you can really organize data and you have a lot more options, because SPSS, because it is package. So you can understand from the word statistical package for social science. So it's a ready-made package. Yeah, you are not doing anything. You are not applying any formula. So formulas we have learned, like standard deviation. In Excel, you have to still apply the formulas, isn't it or not? When you work on Excel and you have to remember certain formulas. But in SPSS, you don't have to remember any of the formulas, because just you put, and we will see today, it will give you answer, okay? Or in other software also. And that's why you better organize your data in Excel and then import from there and work and analyze here. Like yesterday, I think one girl wrote to me that box plot is really difficult in Excel, to be honest with you, but you will see in today in SPSS is just like one click and boom, nothing. Okay, so here the next is data view, and you can see you can put the data here. If you want copy paste, you can also do copy paste here. Okay, whatever. Let's say I am actually 24, 25, my gender. And gender, now it is not going to be number, so it is either 1 or 2, isn't it or not? Because we have already, let me just drag it here, because I will have some. Okay, so 1, 2, likewise 3, yeah, not 3, sorry, 1. So 3 it will not accept. When I did 3 by mistake, there was a sound. Why? Because we have defined only 2 values in gender. Did we define? We didn't define gender. 1. That's why. Let's say one male, add, and second, I forgot. I think. Okay, I forgot to do. Okay. Okay. Last add change person cannot complete it. Discarded. Results in complete operation.
You should press add.
1 minute. Actually, 1 minute. My screen is now. Now it's okay. Because I moved down, actually, that's why. Okay, so when you go to, let me drag a little bit. So when you go to data view, here you can just 1, 2. Can you see the screen? Isn't it? There's no problem because my screen is moving a lot here. Okay, so like 2, 1. Likewise, satisfaction level also you can check there 1, you know, according to what you have did. For example, for the first guy, you go to the first respondent, and first respondent say, yeah, highly satisfied, so you will put 1. If he says not satisfied at all, so you will check how you have defined this, no answer. Let's say he didn't answer, so in that case you will just write the 3, for example. The second says, no, I'm not satisfied at all, and accordingly you will fill the data. Clear or not clear? This is how you actually put your data. This is how you are going to create all the variables. Is there any question so far? Let's do some analysis, right? Let's create some data in order to just small data, and then we can, let me just clear. So when you clear here, okay, when you clear this data here, if you want, it will be cleared automatically in data view, because whatever the variables you create, it will be shown on data, on data view. Now let's say I have X, okay, X, and X could be anything, age or number, and decimal is weight should remain, decimal should be 0. Label I don't need to, because I don't have to do the X is my number. Likewise, okay, let's take, and I don't have to, actually we can put it in nominal, is always better. Just let's go there, and let's say 15, okay, 23, 25, I'm just hypothetical numbers, 32, okay, 54, and 23, and 78. Okay, simple question. Now you want to know the central of measure of central tendency. You want to measure, simply go to analyze, okay, and you have to 2 options, and 3 in fact, frequencies, descriptive. Let's say if you choose frequencies, just you will see there are 2 boxes, okay, this one, and just simply drag, either you drag it here or you simply click it, okay, click it and put it here, and go to the statistics. And what do you want? As I was telling you, it's a ready-made package. So do you want mean? Yes, I want median, I want mode, okay, I want standard deviation, I want minimum, I want maximum, I want range, okay, I want everything, whatever is skewness. Now we don't need, okay, just continue. Okay, charts, do we need chart? We need histogram chart or bar chart or whatever charts you need. Show normal curve also, the curve, but we don't need now, just to confuse ourselves. Or now, and then it will take like a few seconds, and here is the thing. You get my point? No, now look, I told you missing 0. How many observations? 8. What is the mean? 36. Median 28. Mode 23. Standard deviation is 20 points. So mean and standard deviation, they are very far from each other. Variance is 435. This is just range is 63. Minimax, highest minus lowest. Minimum is actually 15, maximum is 78, and possibly, okay. And then we have histogram, right? We have histogram. This is frequency here. You can actually further go, and you can simply, if you want to create that, it is what is the distribution, for example, you just simply click, and it will ask you. We'll discuss this later, but just to show you, okay, here you can create, and you can see, so it looks like the data is, I have a message, just wait, can we run regression? Yes, we can run regression, of course. We will run regression today, don't worry. So we will run everything. Next is let's see correlation, and with the help of correlation we can see regression also. Okay, Nargis. Okay, let's say y. Okay, this is because we need to the one we see. So let's take the same question actually. 0.84. So we will be seeing that were we correct or not. Let me just delete. Okay, so variable, let's say x type numeric with 0. Okay, values, no, missing nothing. Y also put 0. Okay, unknown, that you can, we can put it in nominal, and then just go to date x. And what was the question actually? Let's say x was 2, and it was 3, then it was 2 again, and is it same? But first, the first one was 3, isn't it? 3 3 2 4 3 3 2 4 3, isn't it? Correct, right? 1 2 1 1 2 1 3 and 2. Okay, now we would like to have we would like to see correlation. So simply just go to analyze option. Okay, and then we would find here that then here actually you can find all those curves actually, descriptives, and then you have correlation. Sorry, you have correlation, you have regression, you have neutral networks, you know, you have forecasting. We don't have that much time, but the forecasting also, the software is very, very nice actually. But Python and others, of course, they are. So compare me with correlate, and this is our bivariate relationship. Okay, then we are going to choose X and Y. Okay, options, right? We will be choosing statistics, and look at here. It is asking Spearman, Pearson, and Spearman. Do you remember I told you that it will always ask you in box? And Candas, you know, Candas is non-parametric. We will be discussing in third week what is parametric and non-parametric correlation. Okay, we will be discussing. So for now, test of significance we will be learning again in third week, not now. Flag significant correlations, okay, yes, we can do. Options, we don't need now any of them. Maybe mean and standard deviations we can do. Okay, when you do the correlation, now look at the correlation here. You have this table, and look, the correlation is actually 0.82, and our answer was, what was our answer? 0.83, you said, right or not? So I think it was correct.
84.
84. So it's almost correct answer, 0.80, right? 825. So coefficient correlation, yeah, here Pearson core. So this is actually Spearman. So now the point, because we did the Pearson correlation, so that's why our answer was 0.84, and here it is also 0.84. Total number of observation is 5. The mean is 3 of X. Standard deviation is 0.7. Y mean is 0.1. Standard deviation is 0.8. And Pearson correlation is 0.84, and Spearman correlation is 0.825. As I told you, that the difference is very minimal, but actually again, depending on the size of data, you know, but again, very close to, I mean, there cannot be two scenarios like Karl Pearson says negative and you know, Pearson says, sorry, Spearman says positive. So those two scenarios are not possible. So significance and all, just avoid now. We will be covering all the sheet, you know, this one. So now, how about the chart? Actually, let's see the chart also, because so for charts to see, just go to graphs, and there are two ways actually to create the charts. I will tell you right now. Just go to the graphs chart builder. Okay, chart builder, and when you go to this chart builder, x-axis, which chart are you going to? You're gonna scatter, I think. Let's scatter, drag here, x-axis, this is my x, okay, and this is my y, okay, and when I do this, okay, when I do this, okay, now you see the same kind of, and now you can understand from here that why it is not 100%. Let me draw the line also, so that, let me draw the line. No, this line looks bad actually. This one. Now, actually this has to be this, that's why it should be correlation, but it is not perfect correlation because it has this point. Can you see on the screen? If it did not have this point, then this line would be like this, and we would have said, look, our relationship is actually 1 because it is perfectly correlation. the relationship is perfect. But in this case, we don't have perfect correlation. Why? Because of this disturbing actually, and that's why. And of course, we can understand from our analysis also, our answer is 0.84. So we can understand that there's a difference between, of 0.15 approximately, yeah, 0.1, what you call 0.6 something difference. Okay, so you want to play with this chart, so you can actually make colorful. Okay, this all is up to you. You can actually color the chart, and there are so many things actually you can do from here, different colors, like you will find different colors and all. You can change and you can play with this if needed actually. Okay, correlation. Now she asked me about regression, but in regression actually I can show you now, but before we have to understand one concept which is called the method of least square actually. But here, if you just want to have a look, I can descript in if you want, for example, charts. So I said to you there are two methods. One is graphs. Okay, yeah, so let me just give a very quick overview. Here you can create line chart if you want, scatter or pie chart. So the one I created, histogram also you can do from here, histogram. Box plot also you can create box plot. Okay, so whatever the chart. And the second is just you go to descriptive, in frequencies, and from here also it will ask you which chart you are going to. But of course, comparatively here you have less choices, so you better go for but histogram, which is important to understand the distribution. Okay, distributions in statistics are actually very important. Our next week, is all about distributions. First class I will be dedicating to probability, and then I will be moving on to normal distribution, sampling distribution, which is very important. And there are a couple of other distributions as well, like Poisson, another, but the most important, the binomial and the normal. Okay, so she said to me that she wants to see, so here, Nargis, right? So here you have two variables, but in correlation, you don't have dependent or independent variables, right? But in regression, you have dependent or independent variable. For example, I said in the beginning that my X is by my advertisement. Okay, so I'm gonna put, so don't make a mistake here, that if you by mistake, for example, you choose X, okay, in independent, then it will completely change the equation, and then your analysis will be wrong. And unfortunately, in SPSS, you rely just on your report, because it gives you reports, like whatever you put, it's going to give you. So we have to be careful. So X is my dependent because it was advertisement. So how much I spent, let's assume that X is your advertisement and Y is your sale in dollars. And the next is Y, independent. And here we will be learning all these, but later. Statistics again, look, R square change, not really needed right now. Model fit is also, because same model we can further predict the values. In advanced statistics particularly, we do this. Okay, plots not needed now, later we would do. Okay, and then just for now I will show you one thing, and some square. Okay, so as I said that here you have two values. For today, Nagia, just focus on this, and because residuals and all I will be covering in my next class. Here you have first R. R is 0.84. Okay. As we have seen, this is called correlation. So whenever you calculate regression, the first it will show you relation, because if it has a relationship, then only regression would be possible, as I have mentioned. If there is no relationship, then it will not show any regression. And the next is called R square. That is our actually R square is our regression. Okay, so what does it mean? 0.714. It means that the change in advertisement what is the, because of the change in advertisement, what is the change on the sale or in the sale? And that is 71.4 actually percent. According to the data available to you, there is a 71 point, if you change into percentage, 0.714 multiplied by 100, it says that because of the change in the variables, like this variable, like from 3 to 1. So first week we spent 3 and we found 2. The second week we spent $3, our sale was 2. Maybe the second week was better for weather and maybe festival, that's why people bought more. The next week's $2 we spent and the sale was 1, 4, 3. So according to this data, what our regression actually says that here, so what it says that according to the figure it has calculated, that is because of the change in advertisement, there's a 71.4% change on the sale, actually overall sale. And then we have adjusted our square. I think for now you just hold on, you just no need to, because we will understand in our next class, for example, residual values. What is residual? Why do we call it, what is adjusted R square, and why it is called R square? Okay. And also we will be learning, for example, if this, and let's say I want to spend $10, okay, then what is going to be my sale? Are you getting my point? Sorry, I wanted to make question mark. What is going to be my sale? If I want to spend, let's say $20, I want to spend $20 on advertisement, then what is going to be my sale, right? And that is actually we will learn through linear equations. Okay, so in our next class we are going to start with linear equation.